define magnetic flux. So what is the magnetic flux? So magnetic flux is given by the equation is B A cos theta, and the theta is angle between B and A. B is a magnetic field strength and A is the cross-sectional area A. Or you can use the definition magnetic flux is a number of magnetic field lines that pass through to the surface area A. So this is a B, and this is let's say you have a surface of area A. So now you have a magnetic field that's passed through to the area A. So this is the flux. And next question is state Faraday law. So Faraday law state that induced EMF. So induced EMF in the circuit is directly proportional to the rate change of magnetic flux. The rate change, the change of magnetic flux, d flux, dt. So this is a definition of how you can use state the Faraday law of magnetic induction. Number B, the plane of the coil of radius 0.2 meter is parallel to the YZ plane in a uniform magnetic field. So the magnetic field is 0.4 Tesla in the positive X direction. So you can draw the diagrams. Question number B, let's say you have this is the coil. If I draw the coil, and the coil is the Y and Z plane. So this is a Y. Sorry, so you just use, this is the Y. Let's say the Y and the Z planes. And now you have a magnetic field through the coils in the positive X direction, because the position of Y and Z is 90 degrees. So this is a direction of the X. So let's say this X. So meaning the direction of the B through to the area. Okay, right, this is 3B, and let's say this is x-axis. So meaning the angle, right? So this is the area A. Let's say the area A. So meaning the angle theta between A and B is 0 degree or parallel, right? And if you draw the this is B, and this is the area A, angle A and B is a parallel, meaning the angle between A and B is equal to 0. So number one is, what is the magnetic flux? So magnetic flux is given by the equation flux BA cos theta. So now the value of the calculate the magnetic flux, right? The magnetic flux through the coil. So now the magnetic, this is number one. Magnetic flux equation is given by the flux BA cos theta. So now if you use let's say this is a y-axis, and this is a z-axis, and this is a x-axis, right? So this is 90 degree, and this is 90 degree. So now let's say you have the coil. The coil is YZ plane. Let's say you have this is a coil, okay, right? The coil is YZ plane, this coil here, and this is direction of the direction of the P through the coil. This is B, magnetic field P through the coil, right? P, and this is the angle, right? Because this is coil, and the normal here, or the area here, and the magnetic field P, the theta between B and A is equal to 0 degree, meaning the B and A is parallel, right? So this is the normal to the coil here, right? So now how to calculate the flux here? So this is B is equal to 0.4 Tesla, and the area A, this is a coil, so you can use the pi radius of pi j square, and the theta is equal to 0 degree, right? So now you can find the value of the flux, magnetic flux is equal to, because j, the radius, you can use this is 0.2 t square, right? And the final answer, you can use a calculator to find the flux is equal to 0.50 Weber. And the next is number 2. The coil rotates clockwise on the y-axis so that the normal of the coil is now 30 degree respect to the y-axis. So this is the angle. The first is A, and the B, magnetic field B is 0 degree. So now the area here is when the rotate at the y-axis, so meaning the B, magnetic field B, is still the same, okay, on the x-axis, but now the coil, direction of the coil here, meaning the A here is a normal here, A is now is a 30 degree, right? According to the question number 2. So this is a situation given by the question number 2. So meaning if you calculate the induced EMF. So induced EMF, this is number 2. Induced EMF is equal to the rate change of flux. So the change t dt is a 0.0. So this is value of the dt is a 0.0. This is 0.050 second. And now the d flux here is the rate change of flux. So the initial flux is 0.050 Weber, and if the coil rotate 30 degree between A and B here, so now you have calculate the flux. Let's say this is flux 1. The second flux when the coil rotate is use the equation here, B A cos theta, and the B here is still the same 0.4 Tesla, and the area A is still the same. You can use the pi j square, radius square, but the theta now when the coil rotate clockwise y-axis, so the normal and the coil is now 30, so you can use the cos theta is now 30 degree. So meaning the theta 2 flux 2 right here is equal to 0.044 Weber. So now you can use the right, yeah. So EMF or induced EMF is equal to the rate change of flux divided by time, or dt t. So now the change of flux is a you can use the final flux is a 0.044 minus minus 0.05. This is initial, and divided by dt in the time t is 0.05 second. So now the induced EMF is equal to, you can use the calculator, this induced EMF is equal to 0.012 volt. Right? Number C,